Hello students. So today discussion is all about the language of chemistry, which is in ninth ICSE. As your half yearly exam is nearing, so this is kind of a preparation for half yearly exam. So we are going to strictly discuss about the points which are very important. We are not going to go through all these things what you are seeing currently. So let's start with the very first point, that is called symbol of an element. So before that, let us discuss what is an element is. Okay, what is an element is, this is very simple. All of you know this as you are in 9th standard. So element is the simplest form of matter. Okay, simplest form of matter. Second, this is the purest form of matter. Purest form of matter, which further cannot be subdivided. Okay, cannot be subdivided. Okay, so as you know, there are 118 elements. 118 elements. Okay, 118 elements, right? So these elements are made up of kind of smallest particle of each kind, that is called atom. Okay, that is called atom. So what is atom? Is the smallest particle of element. Smallest particle of element, right? So which may or may not exist independent independently. Okay, again, which can take part in any chemical reaction. Okay, which take part in any chemical reaction. Okay, so this is what all about your atom is. Atom and element. Key elements are the simplest form of matter. Again, it is made up of smallest particle called atom. Okay, smallest particle called atom. So now we are going to discuss about, as there are elements, we have to discuss about their symbols, how to denote the elements. Okay, how to denote the elements. Okay, so let's start. Key, uh, again, symbol. So what is symbol? Symbols are the symbol. What is a symbol? Sorted representation of an element. Shorthand representation of an element. Shorthand representation of an element. Okay, representation of an element. So as this is a revision class, so I'm not discussing how it is formed and what it is formed. So you know the symbol. So let us write the symbol of few elements. Let's say for hydrogen, the symbol of hydrogen is H. For sodium, the symbol of sodium is Na. For potassium, the symbol of potassium is K. So this is how different elements have different symbols, right? Different elements have different symbols. And as these are symbols, what these represents, actually this symbol represent one atom of that kind of element. Means this is one atom of hydrogen. Okay, one atom of hydrogen. This will be one atom of sodium. Okay, This is 1 atom of sodium, and this is how much? This is what? I'm saying how much? This is 1 atom of potassium. Okay, 1 atom of potassium. Understood? Yes or no? This is 1 atom of potassium. As we discussed the symbols of the elements, now we are going to discuss about the significance of elements and significance of the atoms, water atoms, okay, all those kind of things. So now let's move on to this side. Key, the elements are made up of smallest particle called atom. So these atoms are made up of smallest particles, sorry, subatomic particles. Those are called the subatomic particles. Okay, the subatomic particles means the atoms which constitute. Okay, so small particles like electron, proton, and neutron. Proton, and neutron. Okay, in this chapter we are going to discuss about very few things about electron, proton, and neutrons, because the chapter is called atomic structure. There will be we are going to discuss about the discovery of electron, proton, and neutron, and so on things. So now what is important? It is important to understand what is electron, what is proton, but not their discoveries actually. In this periodic table you have seen the serial number. Okay, you have seen the serial number of elements. Serial number of the elements. So what does the serial number represent actually? Serial number represents the atomic number. Serial number represents the atomic number, and atomic number represents the number of protons. Number of protons, and number of proton represents number of electrons. So how this is? As we already know, the atom is electrically neutral, hence equal number of protons and equal number of electron, because proton carries positive charge and electron carries negative charge. Okay, so from this discussion we are now clear that atomic number is denoted by Z, proton is denoted by P, and electron is denoted by E. So I can write Z is equal to P is equal to E. Z is equal to P is equal to E. So now we can say that if an element is in 16th place, let's say an element X is in 16th place in periodic table, 16th place in periodic table. Okay, 16th place in periodic table. Okay, if it is in 16th place, then what will be the atomic number? The atomic number will be 16, number of proton will be 16, and number of electron will also be 16. So this is how we can determine the number of protons and electrons in an present in an atom. Okay, present in an atom. So now next part is to write the electronic configuration. Why it is necessary? Because to find out the valency and so on things, though it is there in atomic structure, but still we have to discuss a little bit. So now we are going to discuss about electronic configuration. Electronic configuration basically gives an idea about the arrangement of arrangement of electrons in the cell, right? Arrangement of electrons in the cells. And in generally the elements up to atomic number 20 have four cells like K, L, M, and N. So K cell can maximum accommodate 2 electrons, L cell 8 electrons, N cell 8 electrons, and N cell 8 electrons, right? So as these are the capacity of each cell to accommodate the number of electrons, so we can write, let's say for sodium, the atomic number of sodium is 11. That means it has 11 electrons. So first cell we are going to put 2, second cell 8, and third cell only 1, because the remaining one is 1 only. Similarly for oxygen, the atomic number is how much? Oxygen 16, sorry, 8. Atomic number is 8. so it will be 2 and 6. Okay, similarly for chlorine the atomic number is 17. So the electronic configuration will be 2 8 and 7. 2 8 and 7. So this is what the concept of electronic configuration is. From this concept we can find out the valency. Actually this concept we can find out the valency. Hope you are able to understand it. It is revision classes, so I am writing it to the point. So now we are going to study about valency. What is valency? Okay, so valency is what? Well, valency in generally we know it is the combining capacity. Combining capacity. Okay, combining capacity. But basically what it is? The combining capacity of atoms. Okay, so valency is what? The number of electrons. The number of electrons lost, gained, or shared during a chemical reaction. So that many number of electron lost, gained, or shared during a chemical reaction is called the valency. Okay, is called the valency. And why? Let us understand why this term valency is actually. As we know, if this is the structure of an atom, okay, if this is the structure of an atom, always the last cell or the outermost cell is known as valence cell. Okay, is known as valence cell. The number of electrons present in here, the number of electrons present are are called valence electrons, are called valence electron. Hence, as valency is because of the loss, gain, or share of electrons, and it is from the valence cell. That's why the term valency is. Okay, this term valency is. So now let us understand how we can calculate the valency of each element until the electronic configuration, or till the electronic configuration 20 from the electronic configuration. Okay. Okay, so let me write two things. We're talking about valence electrons. From valence electrons. Okay, valence electrons, some element will have one or two or three in their valence shell, and some elements will have 4, 5, 6, 7, and 8 in their valence shell. So how to identify or how to find out the valency of these elements from this number of valence electron? Okay, so when there is 1 or 2 or 3 electrons in the valence shell, there will be loss of electron, and the valency will be as same as 1 or 2 or 3. Similarly, I'll tell you why this is. Similarly, when there is 4, 5, 6, 7, and 8, there will be gain of electrons. Okay, to to make these numbers as 8. Okay, make this number as 8. Okay, so now let us understand if why there is loss and gain of electron. I'm taking two elements. Let's say sodium, the electronic configuration is 2, 8, and 1, and one is chlorine, the electronic configuration is 2, 8, and 7. So you see in the outermost shell 1 electron is there, and the outermost shell 7 electrons are there, sorry. So in this case it is, in generally, in the form of understanding, I can say it is easier to lose 1 electron instead to gain 7 electrons. So it will lose 1 electron and the valence will be 1. Okay, Similarly, for chlorine, it will be easier to accept 1 electron rather than to lose 7 electron. Hence, the valency of chlorine is also 1, right? So, and why this? You see, after the loss or gain of electron, these elements or these atoms have 8 electrons in their outermost shell. 8 electrons here in their outermost shell, which represents the octet rule, okay, which represent the octet rule. That means stability of an atom. That means stability of an atom. Okay, that means stability of an atom. So why the valency is, or why electrons why atoms lose or gain electron? In order to attain electronic stability, electronic stability, atoms lose or gain electron. Okay, this is same in case of sharing also. Electrons lose or gain electrons. Understood? I hope you understood. So now let us understand the number of electron in the valence end, like 4, 5, 6, 7 and 8. So you see, for 4 I have to add 4, for 5 I have to add 3, for 6 I have to add 2, and for 7 I have to add 1, and for 8 I have to add 0. Hence these are the number of electrons that are added to the outermost shell of an atom to make these atoms stable, right? So here the valency will be 4, the valency will be 3, the valency will be 2, the valency will be 1, and the valency is 0, and the valency is 0. Okay, so you see, whose valency is 0, those kind of elements are called noble gases. Those kind of elements are called noble gases, right? Noble gases. So now we understood why there is loss or gain of electron, and how they are losing and gaining electron, and for what they are losing and gaining electron. Hope you understood. Now let us find out the valency of some elements from their electronic configuration. Okay, so first of all, hydrogen. And for hydrogen, there is only one electron, so it will lose, it may gain. Okay, so the valency will be, here I am writing valency, the valency is 1. Similarly for helium, this is 2 and the valency is 0. Why this is? Dekho, in the first cell, in the first cell, and if it is the only cell, then if there are there are two electron, then that element is said to be stable. The element is said to be stable. Okay, the element is said to be stable, and it is called duplet rule. When there is 8 electron in the last cell except the first cell, that is known as octet rule, and this is called duplet rule. Okay, this is called duplet rule. So the valency of helium will be 0. As I told, the valence of noble gases are 0. Okay, then let's calculate lithium. Lithium is how much? 2 and 1, so the valency will be 1 because there will be loss of electron. Lithium, then beryllium, it will be 2 and 2, the valency is 2. Then boron, the valency is 2 and 3, the boron 3. Okay, carbon 2 and 4, the valence will be 4 because it need 4 electron, so there will be a loss of gain of electron. And then nitrogen 2 and 5, so the valence will be 3 here. and then for oxygen the valency will be 2, 6 means 2 here oxygen, then fluorine, the valency will be 1 here, and the that is fluorine neon, so the electronic configuration 2, 8, then that means the valency is 0. So you can calculate the valency of any element by this method till atomic number, till the atomic number 20. Okay, till the atomic number 20. So this is what the valency is. Okay, this is what the valency is. Okay, so now next is there are types of valencies are there, but we'll discuss it later. So now let's understand when there is loss of electron what happens. Okay, when there is loss of electron what happens there basically. Let's say for sodium, sodium has electronic configuration of 281, so it can easily lose one electron from its outermost shell to convert it into a positive ion. Okay, that is 1 plus. When there is loss of electron, that atom will acquired with positive charge. When there is gain of electron, that atom will acquired with negative charge. Okay, so when it is a positive charge, that is because of loss of electron. Similarly, okay, it is about loss only na. So let's write one more example. Magnesium 2, 8 and 2, that will be loss of 2 electron because 2 electrons are there in the outermost shell, so it will become Mg, okay, 2 plus Mg 2 plus. You see, when there is loss of electron, that many positive charge it acquires. Okay, there are 2 electrons, there are 2 charge, 1 electron 1 charge. So this is what happens when an atom loses an electron. Okay, an atom loses an electron. Okay, so these electrons when they lose it are only the valency. Okay, are only the valency, and these positively charged particles are now called, these positive charged particles are now called cation. Now called cation because you know what is ion. Ions are the positively or negatively charged particles. Charged particles. So this positively charged particles are called cations. Okay, these positively charged particles are called cation. Now let us understand about the gain of electron. Gain of electron. So gain of electron means, let us take an example of fluorine. That is fluorine, the electronic configuration is 2, 7, so it will accept one electron. If there is acceptance of electron, that many negative charge will be there. Okay, that many negative charge will be there. Let's say for oxygen it is 2, 6 plus 2 electron, it will be O2 minus. So when there is negative charge, these are called anion. These are called anion. Okay, these are called anion. So this is cation and this is anions. And what are ions? Ions are the positively or negatively charged particles. And how they form? They are formed